everyone. Physicus, the Physics Club of NIT Agartala, it is growing leaps and bounds. We are back with our much awaited alumni talks, bringing our alumni from across the globe. 113 years ago, on October 30th, this very date, a great scientific visionary of India was born in Mumbai. Dr. Homi Jahangir Bhabha, the father of the Indian nuclear program, was an eminent physicist and the founding director of the Tata Institute of Fundamental Research, popularly known as the TIFR. Dr. Bhabha is an Padma Bhushan awardee, and he was nominated for the Nobel Prize in Physics for 4 times in the 1950s. We are extremely delighted to welcome Siddarth Bhaiya on this historic occasion, marking the birth anniversary of Dr. Homi Jahangir Baba, and it's a very auspicious day that we are holding this event. Pawan, you can now continue from here onwards, and then we will proceed with Bhaiya's talk. Pawan, go ahead. I think your audio is off, Pawan. Can you just switch it on? Yeah, fine.
Good afternoon, everyone. Joining us today is our own Siddarth Rastogi Bhaiya. Actually, he was graduated from NIT Agartala in 2020, completing his both BTech and MTech dual degree in engineering physics. And he is currently doing the PhD research scholar in the most prestigious college, Indian Institute of Technology, Bombay, and working in the field of nano fabrication and nanotechnology. Welcome, Bhaiya, and we are welcoming you to commence your address.
Yeah, Bhaiya. Now you can begin with your talk, whatever you want to
Okay.
say on nanotechnology.
Okay. So thanks for introducing me, Gaurav and Pavan. So yeah. So first thing, let me take some precaution. If I lose the audio somewhere in between, so you need to just send me a WhatsApp message or call,
Yeah, yeah, yeah.
because when I switch off the screen, then I am not able to see this screen. So this actually can happen.
Yeah, yeah, yeah.
Uh, yeah, because I am using external mic,
Mm-hmm.
not
No
this
worries.
inbuilt mic. And yeah, so here is the journey I started. I this sorry, I got the message somewhere. Okay, in the WhatsApp. Okay. So I during March, due to this COVID, our batch left the campus, and then everyone thought we will return in 7 days or 10 days, but that time never came. Then from June to till December, so I took the admission here in 2020 December. So it is basically a uh, fabrication or purely quantum computing experimental work, nothing simulation like, and purely experimental work. So let me say in this way, there is nothing theoretical. So that is why I prepare my slide in this technological manner, not this. So if you are from the electrical background, then you will basically like it. So the working area in NIT Agartala. Uh, so this is the actually part that people always encounter me. So working area in NIT Agartala my was completely theoretical, and it is so much theoretical that it is in black hole thermodynamics. And here it is the so I already take the precautionary will. That is why. So it is so much diverse that right now I am doing completely experimental and quantum computing side. So that is how it is. So but yeah, as long as you love the something to do, this switching thing in life will ever happen.
Yeah.
So let me start. uh,
Mm-hmm.
so I prepare the one presentation
Mm-hmm.
for you guys. Okay, so let me see where is this screening sharing option. Okay, this one. Okay, so you can stop me as many times you want in between. So feel free to do this.
Yeah, we can see
Oh,
your slides. Yeah,
yeah.
nice.
Okay. Okay. So okay. So hi. So fabrication, my topic of today's talk, and it is more in a technological manner, as I said, fabrication of quantum dots towards realization of a spin quantum computing architecture. So this is the part of my project here, to develop a architecture that can sustainable with this spin quantum computing things. So so here I am not a I didn't took the admission in the formal way in the physics department, but in the CRNTS department, which is Center of Excellence in Nanoelectronics. So this is the part of the center. There are many centers, so I took the admission through that channel. So my supervisor is Professor Sudasatta Mahapatra. He's from physics department, and he actually gave uh, very tremendous fame during his postdoc when he constructed a single electron transistor. So if you just go and type on the Google, what is the single electron transistor, which is a very fancy thing nowadays. So you will see. And my co-guide is Professor Kasturi Sa. She's from electrical department. So and what you are seeing in the background, actually that has a very special purpose. So this is the part of this architecture. I will explain you in my further slide. So just remember that at the end of the day you will at the end of the slides you will again see this thing which is in the background. So here is the outline of the talk. First I will go through you what is the classical width. So then by knowing the classical width, how you actually switch to the spin qubit or spin quantum bit. Then to realize this spin quantum bit, you need to know a architecture. So which is in terminology known as spin quantum computing architecture. And for realizing this spin quantum computing architecture, you needs to fabricate, and this is the experimental part of the project. You needs to fabricate in the lab. This is the clean room lab. So you need to fabricate a process quantum dots. So this is the clean room labs, and after that, for realizing those quantum dots, we need to patterning what is known as surface gates. So this is roughly the outline, but we will come on those points one by one. So let us start from classical views. So let us take a simpler example.
Yeah.
So we all know. Uh, okay, now I am thinking, am I audible?
Yeah, yeah, you are, you are.
Uh,
Don't worry.
yeah, okay, yeah, okay. So yeah, so let us start with a simple example, that is say what is the classical weight. So let us ask first question, what is the classical weight? So we know that if we open our general CPU, we find the microprocessor. And inside that
Right.
microprocessor, we have lots of transistors inside it, billions of transistors. So billions of transistor inside it, and transistor has its own application. One can use it in amplifier, one can use it in as a switch, or one can use it as they like. I mean, there are tremendous application of the transistor if you search on the Google. So this is a classical type of example. So one can use this thing as a switch. Now suppose if I give a suitable polarity on this transistor gate, then I can turn it, then I can form this channel or deplete that channel. So that is how I can turn on this transistor or turn off this transistor, and that is thing known as classical two-level system. So classical two-level system simply means it can be in a state high, it can be in a state low.
Right.
But so this is the example of classical two-level system, but don't confuse here because I have used it to represent those states. Cat 1, Cat 0, just a classical analogy. They are nothing to do with the quantum. But for the quantum, then this is the classical bit. Now, how you will transform your knowledge from classical bit to quantum bit? Remember, here in the classical bit, the important component is the transistor, and that is how you are able to do this job. In the quantum bit, you need to consider an electron. So where this electron comes from, what type of host structure it should be, we will discuss when the I will move forward. But as of now, so so there are you often heard on the internet there are a lot of qubits, people famously known as superconducting qubit, but the and known as superconducting qubit, and another qubit that is known as semiconductor qubits. And semiconductor qubits has its very bizarre property that it can actually realize or examine inside the semiconductor host material. So so that is so my part of the project is not realizing the superconducting qubit.
Hmm.
My part of the project is realizing the semiconductor qubits that can be realized in a semiconductor material, so silicon, germanium, or say in normal transistor what we have used. So people use the gallium arsenide and other material, but let us let us aside all those things, but consider a electron.
Hmm.
Given that system we have an electron, how that electron come? So suppose I have an electron, but this electron in this semiconductor material, it can be silicon, it can be germanium, it can be some alloy of the silicon and the germanium. This can not be freely moving.
Hmm.
So we need to create some confinement potential for trap that electron. So
Right.
where this confinement potential will come from, I will tell you in my subsequent slides.
Hmm.
So but let us suppose for now on we have some confinement potential and we capture that electron. 3D it's of course 3D. So 3D confinement potential. Now we if we apply a magnetic field, so there is a this is the physics terminology. So if we have a confinement lead to quantization, and quantization leads to discrete levels of states.
Hmm.
That is the simple quantum rule. And if you just go for the, I think, Griffith book, there confinement leads to quantization, they just written those words in the quote and quote. So that is why they use this thing. So if we apply this magnetic field, this quantized state, or in real terminology, which I don't want it to use because most of, as you said, this is all not from the physics background. So
Hmm.
real terminology, ground spin state, orbital ground spin state of this electron will break into two states: spin up and spin down, and that is essentially our spin qubit. That's it.
Hmm.
You take a semiconductor material, confine the electron, and apply the magnetic field. It will just split into those two states, spin up and spin down. And of course, this energy spacing directly proportional to this B, linear order of B. It should be proportional to B because that is how the cause and effect things. So, but the linear order of B. So,
Right.
so this is our quantum two-level system, or one can realize these two level system. So see, this is the classical two level system in which we are using the transistor. We don't have any superposition here. Either we have turn on the transistor, either we have turn off the transistor, but here it is the linear superposition of these two states. So
Right.
this is the quantum two level system, and we can realize the same system in the photonics.
Hmm.
So and there how they are guys are realizing, they are realizing which are photon polarization, namely horizontal or vertical. So, so here in the semiconductor material, they are using the spin degree of, taking the advantage of spin degree of freedom of the electron. Here they are using the photon polarization. They take the beam splitter. If you passes the beam, the beam actually split in the horizontal and the vertical direction. That are also the qubit system. I mean, if you have sufficient terminology to use, that is roughly I am saying that is also a two level system, because we have a horizontal polarization or the vertical polarization. But in which area I am working, not the superconducting qubit, not this photonics qubit, sort of speak, this one, sorry, I am photonics qubits. And uh, I am working in semiconductor qubits.
Hmm. Right.
So okay, so so now what we have learned, that we have the electron in a semiconductor material, and then we apply the confinement. Where this confinement potential actually come from, I will tell you again in the subsequent slide. It was for a moment for that slide. Let's consider this confinement potential already with us.
Hmm.
Then you apply the magnetic field, spin degeneracy, and then you can represent these two space as a linear superposition of two space.
Hmm.
Represent this Hilbert space as a linear superposition of this space, and of course a multiplicative constant alpha 0 and alpha 1, and normality or of this thing, or in other words, anyway, this space has to have uh, has to have real. So if you take the sum of their probability, because electron after all in your space, so if you take the sum of their probability, it should be one, and that is how this information is
Right.
depicted here, that alpha 0 square and alpha 1 square equals to 1. But this is actually a complex manner of right now what you are seeing, it a very complex manner of representing this. I mean, you take the spin up, spin down, but there is a nice manner to represent this, which is known as the block vector. So any two level system, all I am saying, even it is the photonic system, even it is superconducting qubit, if it is a two level system, remember two level system, only cat 0 and cat 1, you can represent in terms of block vector. So block vector simply means the same information that we are seeing here, but we are transferring here in terms of sphere. But here we have open space, here we have closed space. And if we realize this mapping, then you will see if we put the theta equals to 0. So see cat 0 and cat 1, you can map here cat 0 at the, see I have did this color coding. So cat 1, you can actually map this spin up, and then cat 0 you can map spin down. And since total probabilities still has to have 1, and since it is a spherical coordinate system, now you put the theta equals to 0, you will recover the north pole. Theta equals to pi, this vector turns this around, and you will recover the south pole. And what you are not recovering, it actually the superposition of all those states, which will, if this block vector move on the surface of the block sphere, you will recover all sort of type of theta and the phi, and that is how it is your spin cube. Okay,
Right.
so that is all about the spin qubit. So now we are heading actually towards some complication. So as we know, we have the electron, we captured the electron by some applying some potential, confinement potential, and confinement potential just capture this electron. But there is, so, and this is actually a completely experimental thing, what I am going to tell you, how robust is the spin qubit. So see, everything is as of now in principle is working. You can see, okay, if we capture the electron and confine it, but there is something that actually greater than this. So what happened, suppose I prepared my state psi here, which I know. After some time, this vector goes this time evolution, and then we lose our states. So you can't say at this stage that we prepare our state psi, which is representing by this vector, because no matter what you can do, it will dephase automatically, spin automatically dephase. So it just sets the upper limit of your measuring time. So it is just like the, if you are from the electrical background, it is just like the flip flops. So if you giving the clocks uh, to something, say SR flip flop, so your clock frequency should be less than your measuring time, and that is how this flip flop will see in those clock frequency. Otherwise it just go into a transient way. Also, that is the same analog that I am using here. So your measuring time should be in such a way managed that while dephasing or while it's going its time evolution, you need to do your measurement. But so let me say the two time, that is spin relaxation time and dephasing time of this spin qubit. So what is spin relaxation time? Suppose I have the confinement potential, I capture the single electron, then I apply the magnetic field. That's the old state story, it just goes to spin up and spin down state. Now the question, how much time it will remain in the up state, that is your spin relaxation time. So I mean, so upper state is already governed to the spin up and lower state already governed to the spin down. So now I am asking a question, how much time it will take for the electron to relax its spin.
And
So
that.
this is the spin relaxation time.
Right.
And another time, which is more important, it's the dephasing time. Again, just recall, as I told, I am this electron what you are seeing, here basically inside the semiconductor host material, right? But semiconductor host material, we have the lattice sites also, see, and then we capture the single electron. So we have a semiconductor host material. So in semiconductor, we have also the nuclear spins, which can interact with this electron spin. And in terminology, if you will go, this will actually kill your dephasing. So there is something in physics known as hyperfine interaction, which will tell you how actually electron interact with the nucleon. But remember, in our spin qubit, we don't want any interaction, otherwise we lose our information. So all I wanted to minimize this nuclear spin. I mean, this electron anyway inside the, and where this nuclear spin is coming from, this nuclear spin coming from because of the design itself, because after all you need to take a silicon wafer and prepare your device on itself, on that. So when you capture the electron, there is also tremendous silicon crystal itself. So it's this will interact with this silicon nuclear spin. So this will kill its dephasing time. So but if you see, so this will just like flip this in this way, or just loses the information. So our qubit with this interaction loses information. But in technology point of view, we use the silicon nuclear spin, so that our which is happening between this nucleons of this silicon. So if I minimize this, I can't minimize this, because so silicon is already there. You can't do anything. But there is a trick to this. So natural silicon has three isotopes, 28, 32, and 96. But we all know, we found in nature the isotope 92.2%, almost, is 28 silicon. And 28 silicon is already have nuclear spin 0. So what I have shown you here in the schematic, actually the wrong information. So this there is not a much interaction for this electron, because it is something that nature gives you, that wings. This isotope cannot be enriched with other isotope, that is 29 and 30. So 29 silicon also have nuclear spin, but one can purify it and make your silicon up to this 28 isotope, and then you can completely vanish. After all, you can't it completely vanish, but you can minimize this nuclear interaction. So that is how your silicon is fully isolated. And this is how the spin qubit. So that is why I given the title, how robust is the spin qubit. Because if you take any other material, this trick doesn't work, because for any other material there is always a nuclear spin. This will interact with your electron spin, and this will kill your dephasing and spin relaxation time. And let me say that people actually right now showing this T1 and T2 time is of the T1 time is of the order of second. But after all, if you are measuring two things simultaneously, so you need to come the time which is a less the more important for you, that is less than 1 second in both the cases. So if you control that, it is automatically controlled. So now just so okay, so this is just the background of everything. So you have the electron, you have this confinement potential, you will confine it, everything. So now actually see how we realize this. So okay, so this is, I think you all know, this is the simple MOSFET. All I am claiming, even in the simple MOSFET design, you can build your qubit. Now question, how you can build your qubit. And in, if you read up in the net, this is MOS based quantum dots. So what is the quantum dots? Quantum dots is nothing but the single electron, or the can be multiple electron. Just like if I asked you what is the single atom, so single atom, and so quantum dot is just the bunch of electrons, just like the bunch of atom called the molecules. They need to use this terminology for here too. So bunch of electrons is the quantum dots. So let's see how we actually realize it. So we have source and drain. Now uh, suppose if we give the positive bias on this channel, then we create the sorry, positive bias on this gate, then we form the channel, and this channel simply connect this source to drain part, and that is how we draw the current from the circuit, and that is the general structure of any MOSFET.
Right.
From this simple MOSFET design, I am switching to the quantum dot. Let's see how it is happening. So now this is the in industry very well known thing, splitting gate technology. So what you will do, you will simply split this gate into multiple gates.
Okay.
So now see, when you give the positive bias here, this channel is formed.
Hmm.
So if you are seeing these two pictures side by side, see wherever there is the positive bias, channel is still here. See below this I have preserved the color coding.
Hmm.
So here is the positive bias, channel is here. Here also the positive bias, channel is here. But why there is not channel in between? Because I applied the negative bias. So this just deplete those electrons. So remember this positive bias, this just form the electrons. This form the electrons cloud, or negative bias should deplete the channel. So that is why we have this negative bias through which we will deplete the channel. Now if you see the potential diagram of this thing, so where we have negative bias, the potential goes up, where we have positive bias, potential goes down, and here, and if you minimize the dimension of this, whatever this is known as surface gates, that is how I told you initially, surface gates, patterning of surface gates. So if you minimize those things, so uh, you are actually minimize this electron cloud. And if the dimension of this gate is of the order of 50 nanometer, 50 nanometer I am saying,
Hmm.
remember over here, if I show you the dimension of my hair, it is around everyone's hair actually 50 micron to 100 micron. So just see,
Right.
this is the dimension of the 50 nanometer. So if I shrink this gate up to 50 nanometer, then actually I can trap the electron, and that is how you got your quantum dot. So the trick who did trick did this fragmentation of this one surface gates. You apply the positive and then negative, then this. So this is the same thing. I don't wanted to go into much detail. So the original idea is not to create this design at the interface. Remember, we wanted the same thing, that if you seeing this side by side, this side by side. So this is the quantum dot that is happening here at the interface of the crystal. Interface of the crystal simply means you have the silicon wafer, and at the surface you have this quantum dot. But rather what we want, quantum dots at the hetero interface. Hetero interface is again a typical meaning to understand, but yeah, for a moment let's assume, because we don't want our device at the surface, because that is where our periodicity of the lattice had been broken. So surface has a lot of defects in silicon crystal. So there is lot of defects in the silicon. So when silicon crystal comes from the industry now, so you are saying it is 100 plane and 110 plane, but it has a lot of defects. So that is why what people, or technological advancement that they did, they actually transfer those things at the hetero interface. Now see, if you want to take away from this slide, so you now see our surface is actually don't have any dots, quantum dots basically. So here at the surface, which is have a defect, but here at a hetero interface. So that is the advancements that people are doing. So this is just the top view from this is sorry, this is the top view of. So right now what you are seeing, this cross sectional view, but here it is the top view, and this is the true image. false color SEM image. So after this device has been made, so we first need to put the CAD design and all those stuff is there. There are surface gates, accumulation, depletion, and so depletion is simply which is depleting this channel.
Mm.
So this is from the top surface, it looks like green. So I again preserve the color code, this green one, depletion gate, then accumulation, which actually form the channel. See, this maroon one is the accumulation gate, and confinement gate has a special purpose because it is uh, which a complicated understanding. But yeah, for a moment, let's leave this. So these are three level device, and we need to just apply some bias, then same thing. So this is just about my lab picture. So this is actually a central mission of the India, so funded by DRDO and DST, in which project I am working. So, and my goal is to form a qubit, not just a double quantum dot. Double quantum dot, remember what is double quantum dot? You are forming these two dots only here. But if you increase these gates in a linear array like this, see, there are multiple dots here.
Mm.
So my goal is to achieve that one in my PhD part. So the people call it linear qubit array.
Mm.
So this is the 5 year roadmap of mine. So this is the collaborator and search collaborator and my uh, and technical expertise in this advisory. Thank you, because I think it took so much time.
Yeah, no problem. So now we will ask the audience if they have
Yeah.
any questions. They can ask regarding nanotechnology here. And later on,
Yeah.
we will be also welcoming the session for other general career queries as well.
Hmm.
So if anyone has a question, they can ask ahead. Or after that, we will go with our own Q&A session. So, yep. Uh, I think no one has any question right now, so we can begin with our Q&A session. So
Okay.
Shubhonil and Krishna will be beginning with your career journey and questions regarding that. So yeah, please
Yeah.
go ahead, Shubhonil.
Good afternoon, everyone.
Yeah.
Yeah, like all the stories which begin with the beginning, tell us something about your childhood days. What your earliest moments of being a toddler and the fun you had as a kid. Any memories you remember?
So yeah, see, childhood. Okay, okay, that's actually complicated. Okay, so um, childhood funny things. Uh, okay, actually, I did a lot of. So yeah, so I mean, you are asking in the BTech life or
No, this
at
is
12th or
exactly about the childhood. Very much
uh,
about the childhood, like when you were 6, 7, 10, 12, something like that.
mhm. So so my uh, okay, so one incident that uh, I have, that is actually a not a fun funny things, but yeah, one incident that actually motivates me about a lot. So when I was in and actually I never yeah recall that incident. Okay, so okay, so once I was in ninth class. Uh, so first of all, even before uh, joining NIT Agartala, so I just I think everyone used to take coaching in Kota and everywhere. So they have memories from there and all those stuff. So I just took the coaching uh, during 12th class in from my hometown, that is in Bareilly. So my actually I'm from UP and Bareilly. So my hometown is Bareilly. So at that time we have a so that is actually a very funny moment in the sense that so I took admission first I took admission in one coaching and after 2 months that coaching closes. I don't know what happened. Then there's this quota factor comes, and all of a sudden this Bansal classes launch in Bareilly, and then I took admission in Bansal classes, and then I found after 3 months that also closes. Then my father told me, okay, better you don't take anywhere admission, because wherever you have taken, actually that closes. So not to go anywhere. So if I send you in a big coaching, so again you will due to you, it actually shut down. So then after that, what I realize, so and here is the learning, um, not the regret of the part, but yeah, if we have a career guide at an early stage, because right now I'm in IIT Bombay, I'm seeing the BTech person. So there are many people that is actually working the many BTech people are actually part of this project, so engineering physics students. So what I realize about them, so and of course you all have your small brother, younger brother than you, so just guide according to them, according to this. So they have always a greater exposure, greater exposure in the sense that they know they what they wanted to really do in the life,
Mhm.
even at a very BTech first and second year. And the in the life, what really matters is the enthusiasm that you have.
Mhm.
You I have seen them, they are working day and night. In the day, IIT professors class is actually a very hectic class of 1.5 hour, and even after that they are working in the lab, research labs, just like us. They are even not sleep uh, last 2 days, 3 days, they are regularly working. But once I asked him a question, so you never tired? So what I got, actually that is the enthusiasm that they have
Right.
to work. So that actually motivates him. So if you have that thing, so that is why at the very first place I told you, uh,
Mhm.
even as long as, because from switching completely uh, theoretical to experimental field,
Mhm.
sometimes, because I never like the condensed matter, and that is the important keynote, if you ask me. Even when I have the choice to consider their condensed matter and quantum field theory, I took the quantum field theory.
Right.
But even though I switched because I like the physics,
Mhm.
that's how in the life matters. Even in my batchmates, we are the part of the robotics club
Right.
at that time. NR robotics club, yes,
They are
NR robotics club.
they are building some stuff for the tech fest this time. So
Yeah.
maybe we can send you
So, oh,
pictures.
you are also the part of this club.
No, I'm not the part, but my
Yeah.
roommate
Uh,
was. So yeah.
so the last alumni, Divya Jyoti, is
Mhm.
actually the president of that club.
Okay. Okay. Okay.
Yeah, I don't think she told you. So yeah. So apart of the side, all I am saying, this really doesn't matter. If you like, so if you invest any penny, if you wanted to invest any penny on something else, rather invest on the education. That will give you a big return. So uh, funny thing, I don't know, because now it's around 7 or 8 years in my life. Then I passed the 12th, 5 years in MTech, then 2 years here, around 1 year, 1.5 year, so 6.5. But yeah, so whatever you are doing, even if you are in CSE department, you are in electrical department, you are in physics department, people always tell you their look, faculty is not good, NIT-A faculty is not good, facility is not good, and all those complainings are there. Mess food is not good. Believe me, this situation also true in IIT Bombay. So
Yeah. Yeah. Sure.
this is the problem of India. This is the problem of not particular institute, not particular. I know that there is a difference. I can't comment that they are equally good and they have lots of exposure than NIT-A. But if you have the caliber, just go straight and वो है ना कि अकेले चलो, खत्म, कोई फर्क नहीं पड़ना चाहिए.
So, Bhaiya, on that note, we have a few more questions
Mhm.
to ask.
Yeah.
Krishna will go ahead with the second question. Yeah, Krishna, go ahead.
Mhm.
Good afternoon, everyone. My voice is coming.
Krishna, your
Yeah, yeah,
voice is a bit low. Can you speak a little loudly? Yeah, Krishna.
yeah. But
Hello.
it is audible. It is
Hmm.
audible. Even if you,
Yeah,
Okay.
Krishna, go ahead.
The teenager life is full of hardship, confusions, and tough academics. So, what was your adolescent like? Especially if you have some good memories from your high school life that you wanted to share with us.
Mhm. High school life. Oh, I don't know why.
So
All are
he
you
is
just
basically asking
pushing,
about,
pushing?
yeah.
Yeah, pushing us, pushing me in. Okay, before 12th, high school life. Okay, so so okay, so sorry, it's about again the funny things or it's about something.
It
I
can
lost
be
the
about
question.
any memory, but if you have any some
Yeah.
like,
So
interesting.
how you all wrote your board exam on the okay. So it is basically on the right bench and top,
Yeah.
right? There is a dedicated desk for that, and in my case, actually, this is the first time that okay, yeah. Anyway, 10th is the first time of board education. So when I give go to the center,
Hmm.
we sit on the dari.
Okay, so there was just carpet around. Uh, that
Yes.
is how you are
So
given.
that is the, yeah, and even in that room there is not any light. So I need to take this this emergency light, na, this
Yeah, yeah.
LED. There are
It,
lots of I don't know LED lights, right? LED lights. So I sometimes I take that thing, and the another yeah, I did my schooling from yeah UP board. So this is a uh, uh, boys school. I mean, not the this. This is
hmm.
the boys school, and yeah. So their actually funny moment are very less. So memories are with them. Those are actually in a co-ed college.
Yeah.
So in that sense, so we all have वो है ना कि only boys. So so that is why memory is always less. So if you have the co-ed, so are you? I think in co-ed college, right?
And
Before 12.
I went to a co-ed school. The college is obviously co-ed, and I think other
Yeah.
students also went there. So,
That is why you all want this
but
memory.
the sad part is that, in fact, due to COVID, this school memory was also shattered for many students. So,
Mhm,
COVID cut short school life really heavily. Moving
mhm,
on, Shubhanil will ask the next question. Yeah, Shubhanil, go ahead.
mhm.
You took the JE, which is in itself a challenge. The course
Yeah.
load is heavy, and there are obstacles unique to every aspirant. So, what was it for you when you faced the JE?
Yeah, as I already told, I actually switched into coaching.
Hmm.
So first coaching went off after 2 months, and second coaching went off after 3 months, and that is how I lost my 6 month till December.
Hmm.
But then I start this preparation by taking the DLP notes, distance learning programming from Fiji,
Hmm.
and I took the admission. Sometimes I during January to March they have some crash course type. I did that and I write the exam. And at at that time I don't have a good decent rank. Then after I dropped a year, and then again I wrote the exam, and then
Hmm.
I took the admission in NEET. So yeah, in terms of obstacle, uh, so everyone has a good memory or bad memory, but yeah, this preparation time is always the best time. After that, first time in the sense that you will see the competition, you will see the ranks, and you will see the if I got this rank I never get any college, even in gate when I was writing this gate exam. So there are lots of things, because during the I mean, so better question would be, because there it is actually easy because you are dropout, and here it is actually tough because you are preparing the academic that is institute academic, and preparing the gate.
Mhm.
So here it's a bus task, and the exam that all that happened during February. So you actually get the 6 month till December time for preparation. So because you start in the May, June, and then December come, then almost February, first week of February, all the subject gate exam has been over. So yeah, you need to manage. And sometimes I leave the classes in my last year. I don't think it really matters, because
Mhm.
anyway, you are calling me here because I am in IIT Bombay. If I didn't got admission, didn't get any admission anywhere, then you simply forgive me. And that is how the world works, right?
Yeah, yeah.
If you are at a post, then only people remember you, but they don't never talks about your journey. So
Mhm.
that is what I am saying. So just think in life what is actually sustainable, or what is actually fruitful to you. If it's something, if you leaves and something you capture, and this capturing actually gives you lots of gains, then this leaves. Just leave this without any thought of second.
Mhm.
So yeah.
Krishna,
So
go ahead with the next one.
Bhaiya, you joined
yeah,
NIT Agartala in 2015.
yeah.
Where were you happy or kind of disappointed when you first arrived here? Tell us something about your first
uh,
impression.
okay, so yeah, now you ask the right question. Now I am happy now, because this thing I have a memory. So, by the way, just let me ask the question to all of you one by one. How you actually arrived at NIT Agartala? By aeroplane, na? Or oh, by train? Oh, okay, because in your time there is a train, right?
Yeah,
This Rajdhani, I think.
yes.
Oh, in our time there is not any train,
Yeah, yeah,
so
yeah.
even track is not there. But I am the first person in my uh, in my I don't know. Yeah, no, no. There are lots of person who actually arrive in IIT Agartala by bus,
Okay.
because I just came to Guwahati, and then from Guwahati there is some landslide and all those things
Hmm.
uh, happened. So it's actually took near about 3 days to reach me there.
Right.
So yeah, but yeah, when you see the NIT Agartala at a very first glance, written in that board, National Institute of Technology Agartala, राष्ट्रीय प्रौद्योगिकी संस्थान अगरतला, तो थोड़ा ग्लिम्स तो आता है, उसके बाद अंदर रोड वगैरह देख के कि हाँ चलो कुछ तो जगह है. But yeah, as I said, these all thing really doesn't matter. People will complain, people will do कि ये कैसा इलाका है, यहाँ पे ये नहीं जाना है, वो नहीं जाना है, डोमिनोज नहीं है, यहाँ वो नहीं है, बाहर कुछ नहीं है, जंगल है. People will do always complain.
Hmm.
Even in IIT-B, in this posh ilaka, people are doing complaint. So people always like this, but
Right.
choose according to this. So yeah, but first glimpse of mine was always good. And I always like the hostels of, because I am very overwhelming by seeing these doors and uh, this hostel. Yeah,
Okay.
because NIT Agartala hostels are actually very good.
Hmm.
This is
Did
actually
you
a
live in the R&T hostel?
no. Actually R&T hostel has small rooms, but when you go to Aryabhatta, na,
Yeah.
they have a big room. So and that is actually a good room. When I even find uh, after entering in IIT Bombay.
Hmm.
So they have a small almirah and everything ना कि space बचा के बनाया है इन्होंने समझदारी से. वहाँ ऐसा नहीं है. वहाँ अच्छे से बड़ा रूम दिया है और सबको अपने अच्छा बट वहाँ डबल रूम है. ओके तो यहाँ
Hmm.
सिंगल रूम. बट या
Yeah,
एनीवे
but
those
but for
hostels are good.
fourth year and final year students, it is single room, so that is good. No problem.
Yeah. Okay, I think R&T they have allotted a single room.
Yeah, yeah. Third years, fourth years, fifth years, these are
Yes.
single rooms. So that's nice.
Right. Right.
So Pavan, you can go
Right.
up with the
So
next.
so if anyone, okay, so just summarizes his question. If
Hmm.
you really wanted to do a job or careers research thing in India, especially in India, I'm saying because during COVID time it hits a lot, so people are not applying to abroad in not able to applying in my time in abroad. So do the preparation of exams, and this actually saves lots of things. Your basic knowledge will increase. and you will actually feels good by the time when you start, because I think I am seeing here is 21 enrollment number, so you are actually in second year as I am seeing this two-person UCH chemical engineering, I think electronics, undergraduate chemical, undergraduate electronics, okay, and DSPH, oh, this is physics BSMS, okay. So do your basic strongs, because even if they you crack with decent rank, they call you for the interview and then they nuts you. So they ask you a question that is actually solved if you actually invested the time on the books and actually invested the time on saves lot of if you invested the time to solve all those things. So just choose a career because you are too young, in which direction you wanted to go, either research, everything is good, even industry, even job, even if you wanted to go in job, programming and all those stuffs. So do a good coding even from today.
Right, right.
So don't waste any time, because by the time you will see that uh, because time goes in that way, right? You didn't realize how it's actually passes. So yeah.
Yeah. Pavan, go ahead with the next one.
But yeah, you take the engineering physics, which is very
Yes.
rare in India because most of the industries are not ready to take like this type of human resource. So how did you take this decision?
Yeah. So okay. So first of all, I think engineering physics in India here, other than in NIT, agar first I am actually very disappointed by their curriculum. So, uh, but as I said, I never claim that. But engineering physics needs to add some really core engineering subjects that they need to add. But at the same time, you can do by yourself. Because see, look at now my research area. I am, even though I am complaining, but my research area is completely in electronics and electrical. You have seen in the presentation,
Right,
right?
right.
It is completely different. Even there is some little bit physics they are using this spin qubit, even if you. So how I took the decision, so decision is somewhat see, first I applied for uh, yeah, so no, yeah, when I did the counseling, now I recalling, when I did the counseling, I actually put electronics on top of this engineering physics. So but yeah, at the same time, after 1 year I have a choice to switch the branch.
Okay, right.
But I didn't did because I like this branch in the sense that, because I have seen the electronics faculty guides and uh, students and colleagues there. So I thought this actually a branch. This can saves me.
Right.
So that is why I didn't switch. But yeah, in principle, I during counseling I put the electronics on top of. So yeah, if you are asking me how you land up in the engineering physics, that is the in that sense wrong question. I actually wanted electronics, but at that time I didn't get. But yeah, I have a decent pointer there in the first year. If I choose the counseling, and I could have switched, but yeah, I didn't take that decision after, because everything goes slowly in this branch. And even I think they updated. We are the first batch, I think. No, we are the third batch. So even more than Deepak Akhare batch, they are. I think their batch is the first batch of engineering physics. And after that, Ban Rishikesh and Hemant Bhaiya, they have the second batch, and then we have third batch. So see how much suffer the first batch,
Right.
how they suffered during their time, because they are not curriculum. They are writing the curriculum on the website. They are not, even though they didn't change. So that is what I am saying. If you sometimes you feel that you love the physics, even you are the electronics person, then after if you book reading the book solid state, any solid state Sanjay Kumar Banerjee and Streetsman book, you will see there is a lot of complexity that can be understood only by the physics people, and that even in here, many people call me in the room for understanding of this Venn diagram,
Mm.
because they can't understand very well,
Mhm.
because that much basic we have. So that is how the, and even in my group there are some person from the electronics, some person from the electrical, some person from CSE, and I am from the physics basically. So that is how it managed. So at the end of the day you will learn everything, but keep note down, strong your basic. That is the only savior that you have in your life.
Right. Shubhanil, you can go up with the next one.
The college lectures are very different from the JE classes. At times, they are not even relevant and seem more like a drag of time. So, did you experience the same in your undergrad, or did it hinder you in the long run, or did you find your own way about it?
Okay, that is the best question that I found till yet. So I am repeating your question. The question I think you have asked, when we attended the JE classes, the technicality and the level of the discussion is a bit more and bit are like that teacher actually knows everything and they are delivering their lectures, and at the same time we are not getting that quality of lecture here in NIT.
Yeah.
So how you actually manage, because we all comes from the JE background, so we used to see those uh, this fastness, this sharpness in the language.
Mhm.
So yeah, so I think you all probably, because you are the younger generation than me, so all probably know about the NPTEL.
Mhm.
NPTEL.
Yeah, yeah.
So, and right now they have a dedicated, very good platform that is known as SWA by AM, SWAM.
Right, right.
SWAM. So just go and register there. Whatever your professor is telling you in the class, say if it is the, if you are from electronics background, you have the signal and system course.
Mhm.
SNS course, if you are attending from there, it is good, even though they are not delivering the right lecture, but it is your job to do the things right. At least understand from your side. So watch those lectures. There are 20 or 24 lectures
Right.
that I think every professor take, and
Mhm.
go and prepare the notes. That's the important thing. If you just watch ना like this, okay, चलो कोई, क्योंकि ये नेटफ्लिक्स नहीं है, यहाँ बैठ के सामने चल रहा है, पिक्चर खत्म होगी, मजा आ रहा है, वो नहीं है. Prepare the notes.
Right.
So at the end, you will see the notes and recalls everything, and that actually increases my level of knowledge when I was in NIT a
Mhm.
lot. I have watched almost every physics lecture series of NPTEL, at least what I need around that time.
What about MIT
So
OCW?
yeah, MIT. See, that is what I am saying. Now there is a lot of cultural difference in India, and see, MIT is also good.
Mhm.
MIT OCW, and if you go to the Stanford lectures, there is a dedicated website.
Mhm.
So that are also good. But here they are teaching in a more advanced manner, in the sense
Mhm.
that, see, they all are, first of all, in the sense that they will signal, and say if you any in general take the course, they will teach you, they will tell you the formula and all those stuff, how to drive, but they didn't tell you at the end the use of this formula. So even in the NPTEL you will see this glitch, you will find. But I am not saying that is bad.
Mhm.
That is good in the sense that right now you are just in the undergraduate, your basics needs to be too strong. But in MIT lectures, you just need to watch out, and you will find the curriculum, basically the curriculum difference.
Right.
Because what is the throughput of how many lecture series you can watch? Even you can go to the YouTube and सर्च करो कि किसी का भी लाखों आ जाएगा. दिल्ली में कोई पढ़ा रहा है गेट एकेडमी, दिल्ली में कोई मेड इजी आ रहा है, कोई भी आ ही जाएगा वो, तो तुम सर्च मारोगे जाके.
Mhm.
प्रॉब्लम ये है कि वहां से देखना किसका है, ये तुम्हें डिसाइड करना है, जिस जो एक्चुअली फॉर यू इट इज फ्रूटफुल.
Mhm.
So I have watched MIT series sometimes, that, but once you understand the basic now, what you will discover, you watch any lecture series, that will actually digest it. So
Right.
you can digest any lecture series after that. But once you watch a full lecture, because I have seen the people, they just register in the NPTL, watch 4 lecture, then they go to the MIT, then they watch 5 lecture, then they go to the Stanford 5 lecture, इतने में सेमेस्टर खत्म, तुम्हारा कोर्स गया, क्वांटम मैकेनिक्स गया, स्टैटिस्टिकल आ गया, इधर सिग्नल सिस्टम आ गया, फिर तुम कभी उस पर रिटर्न भी नहीं कर पाओगे, क्योंकि तब वहां नए लेक्चर आ गए, वहां नए सब्जेक्ट आ गए, तुम कभी रिटर्न नहीं कर पाओगे फिर उस उन कोर्सेज पे। बेस्ट टाइम है जब वो कोर्स चल रहे हो तभी उनको पढ़ा जाए। तो अगर तुम उस समय इसमें फंस जाओगे, ओके नो आई नीड टू सी एनपीटीएल, नो आई नीड टू सी एमआईटी, नो आई नीड टू see this, so take some standard books and watch the lectures, so whatever you like, even if this standard books and your pace is matches with the MIT, doesn't matter, but watch the full। it is not like कि मैं MIT के देख रहा हूँ तो बहुत बड़ी तोप हो गई, NPTEL के देख रहा हूँ तो वो बहुत नीचे, ऐसा नहीं है। जो देखो वो पूरा खत्म करो, तो एक
Right.
सेमेस्टर में वो भी करना टफ काम है। ये नहीं कि 4 इधर देखे, 4 उधर देखे, 5 उधर देखे, सबसे बस बेसिक ही समझ में आ पाया, जब एडवांस की बात हुई तो बस। दैट्स थिंग, सो बी
Yeah.
फिक्स
So,
ऑन
so
वन
the
पर्टिकुलर
takeaway
थिंग।
message is that complete whatever you start learning and don't leave it
Yeah,
anywhere.
yeah, don't leave.
Yeah.
Even if it is not good, it's paining you too much, it is out of the syllabus, but you will see somehow you are connecting the dots. That's it.
Pavan, you can go ahead with the next one.
Yes, Bhaiya. Bhaiya, you said that you did not like the curriculum. So as semester
Uh,
goes on, and you lose your interest, motivation, or somewhere, how do your the classes goes on of your engineering physics? Because you said that you did not like the curriculum.
okay. So, sorry, because I just got one message. That is why I am just repeating your question. So, you just told me that uh, uh, I don't like the curriculum, and so how I overcome this. This is the summary of your question.
Yeah, yeah, yeah. And we are even
Yeah.
sending
And
you that
so it
question.
goes on.
Sorry, we are.
You can even read the question because.
Okay, so as the semester went on, did you lose interest or yeah, sometime this, yeah, I can understand because it is very easy to say from my side in words. I can say to बड़े बड़े वर्ड कि ऐसा होता है, जी बुक पढ़ लेना, वो बड़े वर्ड जब वो जिसको फेस आता है, that they need to, मतलब उसको ही फेस करना है, that they need to face, and yeah, demotivation sometimes and maximum times actually comes. Even motivation time and demotivation time is actually 20 to 80% if you figure out the ratio. And that is why people I am seeing there is actually deviating from the path, because I have seen, so I have seen when I took the admission in NIT Agartala, even there are a person who has the rank, I think 6,000 in mains,
Mhm.
6,000, 7,000, and somehow I don't know how he lands there. But just remember one thing: everything and everything has to have pass. Whatever ranks, whatever things you got has to have pass one day. Even in the research data, which I will collect from those labs, is only work for 5 years. After that, that research will eventually get old and some new technology come, then I need to learn that too.
Mhm.
So that is how life should be. Your attitude always be like a learning attitude, even if it is not from your background, even it is not from, see, if he is from physics and you are from electrical, and you are asking him, see, what is the inverse Fourier transform of something, and because they will calculate theoretically and you will, I think, just see the waveform and tell him, look, I know. So that is actually a learning. So don't be get demotivated, and something extra you need to do side by side. That is why I always take the name of this robotics club.
Right.
So that is actually my point, when I just um, start. So this is actually a technical club there,
Mhm.
right? So just go there and involve them, and whatever they are doing, just try to help them, or uh, they are actually a, I think, a only technical club there. So most of the time I spend there and then, but you need to prioritize, right? So
So some good
there
news,
are
let me share you. So now we
uh,
have multiple technical clubs. We have an ARC,
oh,
then we
okay,
have a aviation aerospace club known as ANIMA.
okay.
After that, we have coding clubs. We
Hmm.
have cultural clubs from singing like Malhar. NLC looks for the NIT-A literary club, which is the literary part of the NIT student cultural
Hmm.
body. And
Hmm.
one of the newest clubs is Physicus, the physics club of NIT Agartala, and we'll be also presenting in the Tech Fest. So it
We
has
tried too
grown.
hard for opening that club,
Yeah.
physics club, but yeah, who is the faculty advisor of that club,
Subrat
physics club?
Prakash Mondal sir is the faculty advisor.
uh, okay. And so he's now HOD, right? Aparna ma'am took the
No,
retirement or
Aparna
what?
ma'am is still the HOD. She will be retiring next year. Yeah,
Yeah, so I think SPM is
yeah,
SPM, or I think Vishwajit Paul.
yeah, yeah. Either of them
Yeah,
will be taking up the.
yeah. uh, Actually. So okay, so let me just give your final. So yeah, these phases will come.
Hmm.
Even in research, I am telling you
Hmm.
that okay, keep motivating. Even in the lab, if I didn't get the result after working 1 week, if I
Mhm.
characterize them and I didn't get the result, I also demotivate.
Right.
And you even can't imagine, see how much time we spend in the lab and not getting the good result.
Right.
So this demotivation phase always be with your life. It is just like your shadow. You can't remove it, but you can always deviate it by uh, by by this light bulb,
Hmm.
by this light bulb which is actually giving you that shadow. So keep in mind. So yeah, demotivating is actually a good thing, because that is how you are mirroring yourself, that you are actually doing something. Because जिंदगी में हमेशा खुश रहना ही है, तो इसका मतलब तुम कुछ नहीं कर रहे हो। हैं, जिंदगी में इतना खुश कैसे हो जब जिंदगी में बहुत लोग दुखी भी हैं।
Yeah.
इसका मतलब सच में तुम कुछ कर भी नहीं रहे हो। डिमोटिवेट भी वही होता है जो एक्चुअली कभी मोटिवेट हुआ रहा होता है, मतलब तब उसने कुछ किया होता है।
Hmm.
डिमोटिवेट तो हो गई ना जब काम नहीं हुआ, तो अच्छी बात वो पता नहीं, वो कोटा फैक्ट्री का शायद डायलॉग मेरे को याद आ रहा है कि वो तुम्हारा बच्चा बड़ा हो गया, बट वो बोलता नहीं है।
Right.
तो वो एक्चुअली ठीक है, सही है, डिमोटिवेटिंग हो गए। सो इवन लास्ट 2 days, इवन दीपावली पे मैं अभी घर नहीं गया, राइट? सो
Mhm.
देन अराउंड दैट टाइम आई वाज टू मच डिमोटिवेटेड। सो I mean, feeling is not good. I don't know what is this anxiety or what is what, but yeah. So that phase will come even in your uh, in a job, in your research career, or anywhere in life.
Yeah.
Demotivating phase, but you need to take
Yeah.
all thing care of by yourself.
Hmm.
No one will take care you. Even someone will take care you. This is only a short span of time. You are the only one who will always remain with yourself.
Absolutely. Absolutely.
Yeah.
Shubhanil, you can go ahead with the next one.
Bhaiya, what made you go for higher education? Because now the general trend is like we have to somehow get placed after BTech. So, what was your motivation back then for choosing higher education?
Yeah. So yeah, this is, I don't know where this motivation comes, but whenever I joined my first day of NIT Agartala, I decided at that time not to do this job. I'm not saying that is bad,
Hmm.
because there are two things. Something you don't like, then you can say it is bad, or something you don't understand, that you are saying it is bad. So my case is the second one. I didn't understand the job. That is what I am saying I don't like. It is not that it is actually bad. So yeah, so motivates me simply, again, as I said, I was just always like the actually, yeah, this thing, yeah, from first, I don't know where this comes from, but from even very first day. So this thing I surely say, because he will ask, he asked the question about how you choose the engineering physics, and I said no, electronics is my first preference. Then how you choose this thing? So I said no. But yeah, here, here I let me say, yeah, from the very first day, I like the research, and uh, and research is the thing that always gives you a um, attitude of learning. So you can never say, even professors, they actually learn. They actually give the talks and learn from sometime us. sometimes from other, and sometimes from other their seminars. So attitude of learning is very important, and that is how is research, as I thought. But maybe in industry or academic job, you attitude is same, but maybe the attitude of good talking and good skills, or how you managing the company, how you manage, so that is the things that you need to understand there. So but here, attitude of learning, here attitude of behaving or self behaving. So I just thought, okay, no, I can't fit there, I can easily fit here.
Mm.
And so whatever I will do, but I will first do the research, and then maybe I can land up in the industry or semiconductor industry, who knows. But
Mm.
anyway, this because there are R&D section in the industries, and all those jobs is also there. But yeah, I don't know where this motivation come, to be very frank. But yeah, at the same time, from the first day I decided I will do PhD. I just told my father, even BTech second year, I will do PhD.
What
So
was the reaction like? Just give a one line answer.
uh, first, because they are accepting, sorry, expecting
Yeah.
job from BTech person, and that is the harsh reality for a BTech person. So why you are doing research? But let me say in this way, this is not the question related to particular physics person, because even in IIT Bombay, the actually physics entrance is too less. I
Mhm.
mean, there are 10 or 15 physics people is there in the department,
Right.
but rather than engineering quota
Mhm.
of per PhD admission is more.
Right.
So this is, yeah, but in India, because people are saying, oh अच्छा अभी तक पढ़ ही रहा है बेटा, तो वो आएगा। अभी एक किस्सा सुनाओ, तुम लोग बहुत फनी फनी पूछ रहे थे, ठीक है। एक मेरा दोस्त गया, तुम रिकॉर्ड नहीं कर रहे हो, राइट? आई एम एज्यूमिंग no, you are recording
Not
this.
to worry, we are recording. So you don't have to worry
Okay, then
about
you can record. हाँ,
this
okay then.
dumb talk.
Okay, okay. So अभी एक मेरा दोस्त गया, I will not say his
Yeah,
name.
no
So
problem.
वो घर गया, तो he's in PhD fifth year, I think.
Hmm.
So एक आंटी आके बगल में कहती हैं कि अच्छा बेटा अभी तक पढ़ ही रहे हो, ठीक है, भगवान करे जॉब लग जाए। So so that is the actually riddles. And I know surely, I definitely, even at that time I'm telling you this uh, BTech second year story when I told my father. But yeah, his reaction is good in the sense that they never, they told me, see, whatever you wanted to do, just do. But as I said, the attitude should be always a learning. Then you can actually impact your attitude to them, that
Hmm.
see, I am not wrong,
Right.
because this is what I like and that is what I wanted to do. If
Hmm.
you fit me in another place, maybe I can earn a lot within that span of time, but I will not be happy one day.
Right. Right.
So that is how
And after
I
all, people have
uh,
to believe that there are a lot of research jobs that will open up in India in this coming decade
yes,
because India is investing heavily in the
just
semiconductor industry
yeah,
and all.
just wait for 5 years or
Yeah,
6 years.
true.
You in India actually, they are investing lots of money in the semiconductor industry,
Right.
lots
Right.
of, so मतलब ऐसा सुनने में आ रहा है कि अभी तो गवर्नमेंट पैसा बहाने वाली है
Yeah, yeah,
सेमीकंडक्टर में, क्योंकि
yeah.
इनके पास कुछ अपना है नहीं, अभी सब सेटअप कर रहे हैं,
Yeah. They
तो
have
अभी पैसा
already
बहने
started
वाला है
doing,
यहाँ पे।
as far as I remember,
Yeah,
the government of India.
even even my guide, I think, got thousands of crores in
Okay.
yeah,
Conduct the research.
for those projects that I
Yeah.
showed you.
Yeah.
So
Okay,
yeah,
so we are
so
running a little short on time, so we will
yeah,
be quick.
yeah.
So Krishna,
So
go
is there
ahead.
any
Go ahead
question?
with the next
Yeah.
question.
Hmm.
Bhaiya, tell us
Hmm.
a story about making it to IIT Bombay for your PhD.
Yeah. Okay, and that is again something. So okay, so let me say true words again.
Yeah, but
Okay,
in short, because
so
we are running
yeah,
out
yeah.
of time.
Okay. So see, during COVID time, there is a very less vacancy even in the abroad or even in India. So as I said, I was in the theoretical field.
Hmm.
I am applying, but I am applying abroad too around that time, as far as I remember. Yeah,
Right.
3 or 4 university I applied abroad.
Hmm.
But due to this COVID, I think they are not even checking their mails and checking their application. And in general, if they wanted to take the 10%, they are only taking 2 or 3% in that group. So then open up one vacancy in the CRNTS department that I have seen in IIT Bombay.
Hmm.
So this is actually the talk of my topic, fabrication of quantum dots.
Hmm.
So at that time, I don't know nothing about any project of this thing. I just see the, because I like the quantum physics and all those stuff. I just see the title of the talk and I search on the Google, search on this Google and find interesting. Then I gave the interview. Then I think there are persons. Then Professor Kasturi asked the question. Then they accepted me. They did the email whether you wanted to join or not. Then I in October, November, this is happening. Then yeah, then I took the admission in IIT Bombay. Yeah, but at the same time, around that time, I got the admission. I think IIT Madras, IIT Kanpur, and IIT Guwahati, and IIT Gandhinagar actually rejected me. I don't know why.
Okay.
I don't
They
even
realize
today.
they
Today, I don't have any question why they actually rejected me.
no,
So
they
yeah.
realize that you are way above their league, so they reject.
No, even so, sometimes I feel bad about that. Why IIT Gandhinagar rejected me?
So, did you write the
So
gate
yeah,
exam to get admitted or
yeah,
something?
yeah,
Okay.
yeah, yeah. Yeah, in India, if you
Hmm.
wanted to go anywhere, you need to give the gate exam. There is not any bypass of that. In abroad, if you wanted to go, there is a bypass. You do a mailing to a professor. Then
Hmm.
this was, as I said, if you prepare some exam, then GRE is just a matter of that is actually too easy. GRE and this
Yeah. Go first.
yeah, yeah. TOEFL actually can depend upon the English proficiency
Yeah.
of person, but yeah, GRE particular level is I know because I have seen the paper is too much. Even engineering physics
Hmm.
second year and third year person can easily crack it if
Yeah.
he is actually learning. So yeah,
Okay.
so
So,
abroad I think admission in that sense is little bit
hmm.
because people do a mailing and they are counting. So enormous thing for going to abroad, you need to have some papers. If you have some papers, then you can simply apply. They will simply accept you because they are thinking you have the caliber.
Right, right.
If you have the papers, even in the co-author or in the author or second author, they will simply accept you.
Hmm.
And right now, I think you people have the PMRF facility.
Yeah.
Do you know about?
Yeah.
Yeah.
But it is only for PhD students. So, yep.
Yeah, but yeah, all I am saying when you apply for the, because I am thinking all you are interested in the research, that is why you are attending this session.
Right.
So
Okay, so let's move on to the next question. So, Bhaiya, what were your initial reactions when you arrived at IIT Bombay? And like the academic
yeah,
culture and all, what do you want to say
uh,
about that?
see, academic pressure is too hard here. Even from the transition NIT to IIT, it's too much. Uh, it is literally a transition for me because there you don't have because you lose
Hmm.
in NIT, you lose a hearing of professor. Whatever you are doing, you are just doing on your own. So even if professor says something right, you don't believe him. But here is actually ulta,
Yeah.
right? Whatever professor is saying actually right, but you don't have, you already lose those tendency to hear the faculty and because that is the 5 year actually a long time. You lose the tendency. So yeah, I actually uh, s- some of the courses actually hard for me here. Some like quantum information and computing, and those are actually hard. And yeah, grading system in IIT is literally too um,
Yeah, it's relative grading.
uh, yeah, relative grading and too much different from yeah NIT-A.
Absolute grading and
And yeah, so but yeah, on the other side, if you are doing the right thing and right time submission assignment, then you can easily get 8.5 or 9 here too. There is not any great deal with this. So, but yeah, you from there 8.5 to 9, you don't need to do anything. To here from 8.5 to 9, you actually need to you have to do something special. So you need to really attend every classes, assignment, quizzes. So yeah. So
Mhm.
8.5 and 9 is really 8.5 and 9 in IIT Bombay.
Right.
Yeah.
So, what are your opinions about the current research situation in India? Because we are seeing, fund
Yeah.
cuts and
Uh,
prices are being cuts and all, and then.
right.
But on the other
See,
hand, government is investing on industrial research and all. So, what is your
yeah.
view?
This answer may be, see, diplomatic or opinionated. In that
Mm-hmm.
sense, if you ask somewhere who is going to abroad,
Mm-hmm.
he will always say कि इंडिया में ऐसा होता है, again as I said कि इंडिया में ऐसा होता है वैसा होता है, but see, yeah, so your question is related to more funding.
Yeah, it
Yeah,
is about funding
I
and the
do,
culture of research.
I, yeah, I do agree.
Mm-hmm.
And in this case, I do agree. Yeah, in India, funding is a more challenging thing.
Mm-hmm.
But here I am too lucky under which supervisor I took the admission, or the supervisor that I have chosen, or he chooses me, vice versa. He is actually rich of funds. So he has so much fund that even you can't imagine. So even in India, only 2% have that much fund. So he is that much of caliber. So in that sense, I never realizes in India we have fund crisis, but they are only giving the fund to only the worthy people,
Okay.
not everyone. Because right now what they are doing, they are not doing the fund to IIT Bombay. So previously in other governments, so that is why I told you this may be the diplomatic answer.
Right.
So in previous governments, I will not call the name. So they just give the funding to IIT Bombay, and IIT Bombay uses in various department and distribute it.
Mm-hmm.
So that is how this funding will start, and people will do your experiment and all those stuff, and big machine they will buy. But now this government actually changes everything. They are not giving funding to IIT Bombay. They
Okay.
are giving funding to a professor, a prestigious professor.
Okay.
But when they give the fund, they have a lot of fund.
Right.
So so in that sense, funding is not the issue. But be if you even if you are joining in India, just see the, so anyway, PhD depending upon the professor, just see the productivity of your professor and how much project he have, from which agency, DRDO, DST, from which agency they have the funding,
Right.
or how much tool they have.
Mm.
So in so we have in IIT Bombay, I don't think any of you know, nano fabrication IC nano fabrication facility, namely this IC manufacturing facility in
Mm.
IIT Bombay.
It is in very
So
few places in India, I guess. TIFR Mumbai, IIT Bombay, IIC Bangalore, and all. Very
right,
few places.
right, right. Very few places, and best
Mm.
of the two places is IIT Bombay and IIT ISC.
Yeah, yeah.
Even in TIFR, I have seen some people in TIFR Bombay came here in
Mm-hmm.
uh, IIT Bombay to do their fabrication and device work.
Yeah, yeah.
So it is that much good.
Mm.
But at the same time, not all the faculty can send their student to their center. That is why told you, it is the center.
Right.
So not all the faculty to send student to send this center nano fabrication facility, because you need to pay them.
Mm.
If your guy don't have that much of fund, how you pay them?
Mm.
So facility is there. So there are, even in the physics department, I have seen I am the only, or there are 4 or 5% they are using those facilities because their guy don't have any funds.
Right.
So but yeah, the final uh, answer of your question may be depending upon the guy to guy.
Right. Right. Pavan, go ahead with the next one.
Yes, Bhaiya. It is said that the grass is greener on other side. So what do you feel about your PhD life now?
Sorry, it is said. Uh,
It is said that the grass is more greener on other side. So what do you feel
ah,
about your PhD life?
okay, grass is greener on the other side. So what is this other side actually?
Uh,
Sorry, I didn't
Perhaps
get.
maybe a established job in an IT company and you know.
No. See, that is also because I have lots of friends who is actually working in L&T, and they are in BTech pass out from NIT Agartala. So they are actually got job here, and I usually talk to them.
Hmm.
So you you can say grass is greener. I don't find this statement to be perfect, because when you talk someone and you have a, see, in Japan, I have seen one photo on the Facebook.
Hmm.
So they have just a six this seesaw things, and one side of the things they just put the very heavy person,
Hmm.
and other side of the thing very small person, but there are lots of books,
Hmm.
and that seesaw actually bent toward that side,
Okay.
which they have lot of books.
Books.
Okay, so even I know one of my friend, I will not take the name, he is earning 20 or 24, I think now, right now, 30 lakh per annum.
Hmm.
And he is asking me, he wanted to apply abroad for this higher study.
Right.
So वो जो वो है ना, जो खाली बोतल का पानी,
Hmm.
नॉलेज वाला, वो रुपयों से नहीं भर पाया वो भी।
Hmm. Hmm.
पॉइंट ये था, वो केवल और केवल लर्निंग ही भर पाएगी और नॉलेज ही भर पाएगी।
Right.
दैट्स इट।
This is the reason
सो
why we also
ग्रीनर्स,
see the many IAS or IPS officers even leaving their job and going to Wharton to do MBA or for higher studies. I think perhaps this is the reason, as you mentioned.
hmm, yeah.
So,
Sorry, what's the other question? I missed something.
that Prashant is asking a question, Bhaiya, how to manage different things at the same time, like in my case, study, hobby, future plan. So maybe you.
In here or in NIT Agartala? Here it is actually manageable,
No, he is a second
because
year
in
student.
NIT
Yeah, in NIT.
he's a
He's a second year student.
an okay, yeah. So uh, all I am saying, it is actually tough. So you need to sometimes sacrifice with your friendship zone. So your friends is going somewhere and you also want to do, but you also know that you got time on Saturday and Sunday to watch the lectures, because other than the this uh, weekdays you are actually busy with the classes.
Right, right.
So sometimes you need to sacrifice.
Mhm.
Yeah. So as I said, there is a, you as a person, you know yourself very well. So you need to uh, know how you actually balance your work life and study life.
Mhm.
So
Sure.
this don't need to disturb work life also and study life also. If anything is disturbing, so you need to know how to resolve this, because you are the owner of your own. So
Right. Pawan, you can go up with the last question.
Yes,
last
Bhaiya.
question.
Finally,
Uh-huh.
what would be the advice would you give to the aspiring scientist who was listening today, and in terms of academics, family, enjoyment, yeah, in future days? What is the final advice you want to give?
Sorry, your voice is little bit cracked in between. Just please repeat your
Yeah, we are
question.
also sending you the question. Just hold on. Yeah.
Okay.
Finally,
Your
what would be the advice would you give to the aspiring
history scientist who are listening to you today, in terms of academic and environment for the days to come. Okay. Aspiring advice. Every time this sort of type of questions coming now, I confused. Okay. Okay. So as I said, uh, you will, in your BTech life you will see many ups and downs.
Mhm.
Even if you are preparing a gate exam, even you are preparing your job interview, you will see that the person that actually never attended the class, never attended the, just 1 minute, it's an important
Yeah,
thing.
yeah, sure, sure. No problem.
Okay, pardon me for this. Yeah. So question. Okay, sir. Yeah. So you will see. Oh, okay. You will see that many persons are getting job, even they are
Mm-hmm.
uh, not known to very well about the coding or in which company you are applying. Even my times I have seen this, and you will also face this thing. Then many, even because when people are seeing from just looking from the upside now, they are not looking their hard work, which is always a backside story. So वो है ना, एक वो उन्होंने कहा है कि 10,000, ओके, वो है ना एक कहानी बल्ब वाली, आई थिंक कि वो 10,000 टाइम फेल हुआ जब थॉमस एडिसन ने बल्ब बनाया। तो उससे पूछा गया तुम 10,000 टाइम्स फेल हुए, उसने कहा नहीं, फेल नहीं हुआ हूं मैं, उन्हें 10,000 तरीके ढूंढे जो कि वर्क नहीं करे।
Right. True.
तो तो ऐसा होगा कि अप्स एंड डाउन्स आएंगे, तुम्हें अच्छा नहीं लगेगा, वहां पे कभी छोड़ के जाने का मन करेगा कि चलो अब चलते हैं, करना है, ये करना है, ये इतना आगे निकल गया, कैसे निकला, क्या हुआ, रातों रात कुछ नहीं होता है, सब बैठ के करते हैं। और बट या यू आर यू ऑल आर आई एम एक्चुअली बाय दिस डिस्कशन ना, आई एम एक्चुअली सो ओवरवेलमिंग बिकॉज मेरे टाइम में अगर कोई मुझे इतना बता रहा होता,
Right.
आई एम नॉट सेइंग आई एम नॉट एट अ गुड प्लेस, but there is always a better place
Mm-hmm.
than at at present where you are.
Right.
So better place होता। So and you are so young, I mean बीटेक सेकंड ईयर में इतना सब जान लेना, यहाँ तो थर्ड ईयर में तो जाके होश आया था, बीटेक सेकंड ईयर में इतना सब जान लेना, इतना सब समझ लेना, इतने लोगों से बात कर लेना। थैंक्स फॉर गौरव
Mm-hmm.
because he actually for my eyes, I am not saying that I think you all are the collaborators for him, so but for my eyes at least he did the lot of pinch and every time I don't know what he is thinking कि भैया कितने बिजी हैं, इतने बार मैसेज कर चुका हूँ फिर इसने फाइनली पिंच करना
I know how
स्टार्ट
much
किया।
PhD scholars are busy because जब मैं
या
गया था
या
internship के लिए, so I have seen people are working literally 26 घंटे out of 24 hours. So I know it's a very hectic and puzzling life. So I do not
yeah
push very
yeah
hard.
but uh, yeah so but yeah around that time I was too busy because of this, I told you na,
Yeah,
this seminar
conference.
in
Yeah.
IIT Delhi, yeah. So that is why I was too busy in this week.
Mm-hmm.
So one poster presentation I had. So
Mm-hmm.
yeah, but yeah, that is actually a very good initiative, so keep moving that and call others alumni too. And if any needs you if you need any help in future
Right.
regarding admission in India and just feels bad about something, just leave a message or call me directly. Sometimes I cut, but I will do a call back always.
Right.
So you are free to always do that.
Mm-hmm.
So yeah, but yeah, देख के थोड़ा अच्छा लगा, काफी दिनों बाद इतने लोगों को वहाँ के, but yeah. So
Right.
but yeah, remember one thing, demotivations is a part of the life, just like your shadow. Ups and downs you will see.